Atomic radius increases down a column or family of the periodic table. Let's look at the group 1A. Proceeding down the group, the outermost or valence electron resides in orbitals of increasing size, in 1s for hydrogen, 2s for lithium, 3s for sodium, and so on. Therefore, atomic radius increases from hydrogen to cesium. Atomic radius decreases across a row or period of the periodic table. Let's look at row 3. Proceeding across the row, the effective nuclear charge increases as more protons are added to the nucleus. The outermost or valence electrons reside in orbitals of similar size, in the 3s orbital for sodium and magnesium, and in the 3p orbital for the remainder of the row. The increase in effective nuclear charge pulls the electrons in closer to the nucleus as we proceed across a row. Therefore, atomic radius decreases from sodium to argon. Now, let's look at trends in ionic radii. Click on one of the 3 buttons to begin. When lithium and fluorine react to form the ionic compound lithium fluoride, an electron is transferred from lithium to fluorine. When lithium loses an electron, its size decreases significantly, from an initial atomic radius of 152 picometers to an ionic radius of 60 picometers. When fluorine accepts the electron, its radius increases from 72 picometers to 136 picometers. An electrostatic attraction, or ionic bond, forms between lithium ions and fluoride ions. Let's consider the isoelectronic series nitride, oxide, fluoride, sodium ion, and magnesium ion. An isoelectronic series contains atoms or ions that have the same number of electrons and the same electron configuration. Each of these ions has 10 electrons. However, these ions have different number of protons in the nucleus, attracting the 10 electrons. Recall that the size of an atom or ion is based on how far the electrons spread out from the nucleus. Let's start with fluoride, which contains 9 protons and 10 electrons. To view the size trend in an isoelectronic series, click on the slider bar to move the slider to the left or to the right. Moving the slider to the left will decrease the number of protons in the nucleus. Moving the slider to the right will increase the number of protons in the nucleus. As the nuclear charge decreases, the attraction for the 10 electrons decreases, allowing them to spread out further from the nucleus. Size increases. As the nuclear charge increases, the attraction for the 10 electrons increases, drawing them closer to the nucleus. Size decreases. As the nuclear charge increases, the attraction for the 10 electrons increases, drawing them closer to the nucleus. Size decreases. Consider the change in size in going from iron 2+ to iron 3+ ions. Both of these ions have the same nuclear charge, 26 protons, but a different number of electrons. When iron 2+ loses an electron to form iron 3+, the size decreases. Iron 3+ has the same number of protons attracting fewer electrons, 23 instead of 24. The electrons are pulled in closer to the nucleus, and its size decreases relative to iron 2+.